Okay, kids, so today we're going to start focus topic 2, linear motion. Given the changes this year, a couple of these topics will not be tested, and we need to learn to start looking for them. So just so we're not reviewing skills that you're not necessarily going to need. So it says understand and use the relationship above. So I guess that really is indicating the relationship between position, velocity, and acceleration, right? And so very early on we learned that position, velocity, and acceleration are derivatives of each other. So this is equal to the derivative of this, which is equal to the derivative of that. Distinguish between position at some time and total distance traveled during the period. So the total distance traveled during the period is now no longer going to be tested, right? So total distance, if you look at 8 dot, I believe it's 3 or 2, one of them says linear motion with integrals. So any linear motion with integrals is out. The net distance traveled is displacement. That one's out. Note that displacement has not been previously on the AP exam, but may now be used. It was definitely used in 2019. This is a 2016 document. Final position, again, this is accumulation, and final position, both are out. Initial value differential equation problems. Given the velocity or the acceleration, this could happen. This is chapter 7 where we have that initial condition and you have to find the actual function. Find the speed at a given time. Speed is the absolute value of velocity, so we would take the derivative given position and then absolute value. Find average speed, velocity, or acceleration. This is going to be AROC from the function before. Determine if a speed is increasing or decreasing. We are looking for velocity and acceleration. Same sign, it's increasing, and opposite sides it's decreasing. If at some time the velocity and acceleration have the same sign, here you go, the speed is increasing. If they have different signs, the speed is decreasing. If a velocity graph is moving towards the t-axis, the speed is increasing, away, decreasing. Using the difference quotient to approximate a derivative. This is the old school slope. And Riemann sum approximations. And then the last thing they ask you to do is to interpret the meaning of the derivative. We will not be having a definite integral in the context of the problem. Okay, so that's your overview. I'm going to make another video where I go over your homework problems, and then we'll go from there.